This is going to be the first video of another little mini series where we go through and actually create an ESP completely from scratch. So that means we're going to go through, we're going to find the entity list, the offsets between each entity, well, pretty much the distance between the entity's health, their location, our own view matrix, and all that kind of stuff from scratch. Now, the game we're going to be doing this on is Call of Duty World at War. We're going to be using zombies for this because, quite frankly, I don't like people who necessarily cheat. However, this is something I also have a hobby in, which is kind of conflicting, but I only really ever cheat in CSGO, and that's only when there's some douchebag doing it to me. So, anyhow, to continue, the only prerequisite for this video is going to be the CSGO video number 1, where we go through and we link to the GLFW library and set up OpenGL as well in our project. And the only thing I have done is I have a blank project aside from literally the default example for the GLFW documentation. So that's literally just the bare bones that you have to get a window up and running like this. So that's what we're going to be starting with. So what we're going to be doing in this video is we're going to go through and get some of the required offsets that we're going to need to actually use to draw. So I'm going to go ahead and create a quick little list here. So we're going to need, first off, we're going to need our entity list. We're going to need the location for the entity. So I'm going to categorize these. So entity. So we need the location. We want to get the health. And we want to get the distance between for each entity. Now for ourselves, our local player, what we need to get is our view matrix. And that should allow us to draw from the screen. So pretty much, we're going to be using our view matrix to figure out, we're going to be using a world to screen function to get the position in our screen where we want to draw to the location of the entity. We also want to go through and we only want to show or draw to the entities that have a health greater than 0. And we're also, because we're going to be looping through each entity, we want to make sure we can get the distance between them. So how far do we have to go to get access to the next entity in the entity list? So that's kind of summing up what we're going to do. So I'm going to go ahead and save this, and I'll just do it to the desktop. World at War offsets tutorial. And we can begin. So first things first, simplest thing is probably going to be finding the entity list. So we're going to go ahead and load up into Nazi zombies here. I'm just going to do the first map. I'm going to go ahead and do God and no target, just to go ahead and prevent any issues. And we need to load up Cheat Engine. So load up Cheat Engine, connect to the game, and we are ready. So there's already a tutorial on this. I haven't done it, but he kind of goes more in depth with it. But pretty much what he did was he went through and found the health. So he pretty much scanned for an unknown value, and it kept decrementing from there each time he shot him. So it would just decrease until he found the value for the zombie. Now what I'm going to do is pretty much the same thing. However, I know for Nazi zombies, they always start out with a health of 150. I'm going to start there and just decrease it. Here we have 100. When I shoot him again, it drops down to 75. So that's probably going to be my zombie. So just to confirm, set the value back to 300. And that's definitely it. So what I'm going to do now is I'm going to go ahead and right click and go to browse this memory region, or better yet, it's good to get into the habit of hotkeys, Control B. And then I'm just gonna, because we already know we have the entity here, I'm gonna go ahead and go to Tools, Dissect Data Structures, and just confirm so we know what the offset for the health is. So actually we're on the health right now. So what we need to do is find out what is actually going to be, what is accessing it. So normally, in this case, we can't just attach a debugger because you'll have an issue. Now I'm currently using, where is it? the Windows debugger. Some people get away with using VEH debugger, but in my case that does not work, so I'm going to load up Process Hacker 2. Not going to allow me to view it, or was this 6? There we go. Yeah. And I'm going to go ahead and find Call of Duty World at War. I'm going to right click, go to Miscellaneous, and detach from debugger. Sometimes it crashes when I do this. Thankfully it didn't, but now I can... Oh, come on, Cheat Engine. Alright, well, go figure it's going to crash. So I'm just going to go ahead and save what I have written down, 017A47A8. Did it go? Nope. Just going to go ahead and close it back down and relaunch it. So we have this address. Let's go ahead and add it. 124. And go ahead and see what accesses this address. And now we can actually see it. So I just shot the zombie. I don't know which one it actually is, but I want to go ahead and do... so I don't have to worry about ammo. But we can see here they have a consistent offset of 1C8. So odds are, if we subtract 1C8, we're going to be at our entity's base address. So I'm going to go ahead and take down and write for health 1C8 and save it. So let's go ahead and take this address. We're going to add an address manually. Paste it in and do minus 1C8. And let's go ahead and look at it. So Control B or right click to browse this memory region. And I go to Tools, Dissect Data Structures, or Control D to find a new one. And let's scroll down. So scroll down to 1C8. Here we have our health, and here we have the starting health. So here's our current health, and usually the location should be somewhere near the top. So let's look and see. We should be able to see, it looks like it's going to be these 3 floats here. So this is probably just our X, Y, and Z. So let's see if it changes as he moves, which it's doing. So I'm going to have him walk up the stairs and see if the 1.125 value changes. Not entirely sure which zombie it is, but yes, it is changing and increasing. So this is our location. So we start out at we have an offset of 18. The location is just going to be 0x18. And here we can read that just into a vec3. So we have our health and our location. Now we need to go back a little farther and try to get the entity list. So we need to pretty much just go back a level. So I'm going to go ahead and close that down, make sure I have that saved. And let's see, this was the entity. So we can go ahead and, like in the video, he went ahead through and did a pointer scan. I'm going to go a little bit of a different route. I'm just going to find out what accesses this address. Holy lag. Close it. And just kind of do a quick look through and see if there's really anything that's interesting, because all these are actually going to go through and show the same address. So ESI is the same exact thing. So we need to figure out what is going to really be handling it. So I know in multiplayer, it's an array of objects. However, in zombies, I think it's an array of pointers. So a pointer is just, well, I don't have an example and address right there, but a pointer is just think of it like a variable that holds an address. So we would have a pointer to perhaps this address here that holds the health, just for example. So we're going to look and see what holds the address of the entity. So this is our entity's address right here. So 017A45E0. I'm just rewriting that so I can copy it. I'm going to search for hex, paste it in, and let's see. So we have 3. Let's go ahead and just open one up. Now this one is going to be here, I'll just bring all 3 down. You can see this one is going to be the closest to the address of the entity. These guys are pretty far away, so I'm going to go ahead and delete those, and most likely it's going to be the one that's closest to the entity. I'm going to go ahead and Control B, Control D, and now we have a pointer to 017A45E0. That's this guy right here. So if we break it open, we can scroll down to 1C8. We should be able to see the health, which we do. So we can look again, kind of go down a little bit. And we're going to want to look for more pointers that hold an address very close to this. So so we can just Control F to search. So 017A4 is most likely going to be within range. So let's find the next. And 88 away, we have another one. Let's drop it down, scroll down. Actually, we can look at the top. We can see here's most likely the X, Y, and Z. That's showing as a pointer for some odd reason. Go down to 1C8. And here we have the health again. So we are in the entity list. And if we go down, we cannot go any farther. So we are at the entity list, but we're not at the start of it. So what I want to do is we currently have how many? 1, 2, 3, 4. I'm going to go back. Let's see, these are how far apart? 88 apart. I'm going to bring out the calculator. Go to hex in the programmers tab. We have 17845E0. We're going to subtract 88 and subtract, whoops, dang nabbit. Now we can actually just subtract 80. So I'm subtracting 88 twice. So whatever that 88 times 2 is. So we have this address. So this should hopefully be the kind of the start of the entity list. So I'm going to go ahead and check. I'm going to paste it in. What are you complaining about? You have to have a 0? Okay. And did that actually move us back? Yeah, it seems like it did. So, I'm going to go ahead and create another structure. Not the case. Let's add 88 for 550. And I may have typoed something. Did I? 5D8. Yeah. My guess is here I have typoed something. So I'm just going to go back to that memory region. And I'm right back here. So I'm going to copy it. Subtract 88. Subtract 88. Oh, yeah, I didn't realize how far off I actually was. But I just subtracted 88 twice again from that address. Go ahead, copy it, paste it in. What are you complaining about? 18E7448. Oh, and look at that, we went back another, let's see, what's 88 times 2? I'm being stupid. We went back 176, so here's our another entity. Go down to 1C8. And here we have the health again. So let's go back one more just to kind of confirm out of curiosity. Copy you, and we're going to be at 173C0. And we have a pointer to another entity. Scroll down to 1C8. And here we have 100 out of 100. So that actually makes me question, this might be ourselves. So we are possibly, let me disable God mode, the first entity in the list. Because, as you can recall, the original health was 150. Did I even throw the grenade? Okay, there it goes. So let's damage myself. Yep. And our health dropped down to 23. So if you wanted to modify your health, you could get this entity list, grab the first entity, and that's going to be ourselves. So we have 23. So we have found the entity list here, and we can start from this address. We have the entity list, and we know the distance between was 88. Because if you recall, we have our first entity, we scroll down 88. We have our second one, scroll down by 88. We have the third, is that the 1/3. Math is hard. So 110. So we have this next one and so on. So we're going to start from this address, save it, and we have everything we need in terms of the entity. So we can actually jump over this because we don't necessarily need ourselves, and my guess is we're going to always be the first entity. Now, I could be wrong on this, but just in case, I'm going to go ahead and keep it. And one thing we can actually do to check if we are or not, well, I guess that's not true because Juggernog would modify your starting health. But yeah, whatever. We're not going to worry about it right now. So we have our entity list. Now we have to find our view matrix. So this is pretty much going to be an array of floats that consist of 16 elements inside it. So we're going to want to find pretty much 4 rows across. So 4, 8, 12, 16. So the way we can find that, let me re-enable God mode again. And of course I killed them all. Is when we look all the way up, we have the value of 1. When we look all the way down, we have the value of -1. Same thing when we're looking this way and we turn around, we're going between 0 and 365. Or not 365, 360, sorry. Well, actually 359. But what we're going to do is we're going to search for that 0, or that -1 and +1 value. So I'm going to start a new scan. Delete these two. And just in case I need it for whatever reason. I don't think I will. Entity list. We're going to we're going to do a first search for 1 and look all the way up until we can't anymore. And golly, you are really annoying. I'm going to go out of this map. Or out of that section. So we want to look all the way up. So looking all the way up, we search for 1. And we can also probably drop this drastically by doing unchanged. I stand corrected. Keep it at 1 and move around but look straight up. Oh, wait, what am I doing? I don't want an integer, I want a float. So we search for 1 while looking straight up. There we go. We're going to look straight down and search for -1. Look back up again. Search for +1. And still while looking up, let's move around and turn just a little bit. Just keep searching for 1 again, and it'll keep dropping the values. So I can go all the way up here. Let's crank it up a little bit and still search for 1 again. Look straight down, -1. And probably going to be about as close as we can really get. So I'm just going to search for 1 more time. Search for unchanged. Spam it, and we have 11, actually. So here you can see, as I look down, the values go down to -1. Now we can assume that these are not it because they're -5. However, these are going to be as close as we can get to -1. And same thing when we look straight up. So it's going to be one of these 3. So if we start from the top one, let's go ahead and open it up. So we press Control B again, or dissect data structures. We're going to change this little listing here to display type float. So here we can see our 1. Look down at yada yada yada. So that's partially what we want. Let's scroll up. And we can kind of see this isn't quite our area. I'm just kind of looking through the list again to kind of see what all is dictated, because I see something interesting. I see our screen resolution right here. So that's at 704. So at 734, we have 1. So that would be right there. So that gives me the thought that this first one is not it. So I'm going to go ahead and delete it. And I'll show you what I mean here shortly. So this one is literally just below it. Well, it's not just below. It's actually a little bit of a ways off. But when I look at this guy and scroll up some, let me scroll back to, what was it, CD4. So here's this value. So this one was going kind of across. We can see which ones are moving. It's by the upper section. So it would be these right here. This is not what we want. That's only 4812 total, as well as it's not exactly holding what all information we would want in our view matrix. Well, need to have in our view matrix. However, when we come down a section, so this one's 734, so that starts right here. We can see it still goes to 1 and -1, like so. So we also see our screen resolution. So 1280 by 960, 1280 by 960. So this most likely contains it. So here's our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's probably going to be these values here that are going to be for our view matrix. So that is going to be X, crap, where was I? So here's our resolution. We're going to start right here. So that's going to be 0x 8E87. It's going to be 7C. No, 70C. Because we have 04, 08, OC. So that's going to be our view matrix most likely. So just because I like being neat, 3, 7, 8. Go ahead and format them so they look nice. And without testing, this should be the information that we use to draw. So now that we have everything, hopefully, we will in the next video go ahead and start working on actually writing up the code that we need to draw to the screen. So for that, I'm going to go ahead and go back to the main menu and change the screen resolution to my native resolution. And go figure, it is stopping at 1080 because that seems about right. But yeah, that is going to be all for this video. If you have any questions or anything like that, feel free to join my Discord down below. And if you like what I'm doing and you want to help support me, you can join me in my Patreon, where I have a team deathmatch series where we use C++ and Unreal Engine to create the team deathmatch game mode, along with a couple other things like a weapon customizer and all that. So yeah, I'll see you in the next video where we actually start drawing to the screen. Well, potentially. So see you then.